So this talk is concentrating on work that's been done by myself and my colleague Sean MacDonald, who's based in our New York office. So sadly couldn't be with us today, but I just wanted to acknowledge and thank him for what he's done to contribute to this. So to start with, I'll just talk a bit about OUP. I know Tom gave you an overview yesterday, but just in case you've forgotten, I wanted to explain about our main products and why we're looking at graph data models and what business drivers we have for them are. I'll go through a few different approaches in the literature and what we've learned from them based on what other people have done. I'm going to explain our publishing workflow and XML metadata, and then talk a bit about how we've modelled the RDF graphs from the original XML trees. We're kind of in the middle of moving along the path from XML to RDF and then thinking about linked data. And one of the first steps between just RDF internally and linked data published on the open web is semantic markup. So I'm going to talk a bit about RDFA and schema.org and why that's a possible next step. So this is kind of a similar slide to Tom's yesterday. These are some of the online products that Oxford University Press publishes. We've got a wide range of academic content, so we've got journals from lots of different domains, from medicine, law, humanities and so forth. We also publish lots of different dictionaries and other reference content. Oxford Scholarship Online is chapter-based books, basically. We also publish the Oxford Dictionary of National Biography and the American National Biography. We have Oxford Islamic Studies, we've got Oxford Biblical Studies. We have Medicine Online, Law Online, and we also do primary text data. So this is just an example of a Shakespeare sonnet in Oxford Scholarly Editions Online. So we've got lots of different types of content across many different disciplines. And one of the things I try and do is link these different contents together. So the main motivation for the work that I've been doing on RDF is within our discoverability programme. So because a lot of our products are subscription-based, they're not necessarily easily available to Google and other search engines to index. So what we've done is publish the Oxford Index, which is where each content record, so each chapter or primary text or bibliographic reference, has an index card of the XML metadata, which is published open access so that Google can index it. And we've already found that publishing this type of metadata has really increased the volume of our content that's indexed by Google. So that's the search engine optimization business driver that we have. The second one that we have is to improve our user journeys across multiple products. So in the traditional publishing world, we've really seen individual products as very much silos and separate pieces of content. But for a user coming in from Google, say, looking at the breadth of our online content, they really just want to be able to get an answer to their question, and they care less about individual products or branding. We want to keep them within OUP's content. So it's quite important for us to allow them to explore the breadth of our data. So we might want to suggest to somebody who's reading an article in the Oxford Textbook of Medicine on medical ethics that they might also be interested in a journal article on the same subject. Or somebody who's reading a poem by John Donne in Oxford Scholarly Editions Online might also be interested in a book about John Donne. So we do this in two ways. One is we have dynamic links which are generated as search results. And obviously the more detailed the metadata about the particular documents is, the better the search engine results are going to be. But we also have static links, which either have been edited by authors, so we have is author of, so one particular record on Shakespeare is the author of Macbeth, for example. And we also have primary topic links, where we've collected together a lot of different content records and brought them together in what we call overview pages. So these static links are stored in a database called the Metadata Hub. And because we've got a lot of links here, we've started to think about RDF as a graph model, which may be a better way of storing our data than just in XML documents. So, what's been tried before? 3 different items I wanted to mention here. One is a paper from MarkLogic at XML Prague this year, where they were using XQuery to construct triples from XML. We've actually been using XSLT to convert our XML where necessary, but it's the same kind of thing. And they suggested using URIs to link from the XML document to the triple, say. Our documents are all identified by digital object identifiers, DOIs, so we've used them as URIs in our triples. So we're following that same pattern. The BBC have done a lot of work in semantic publishing. So one example they have was with BBC Sport, where they've got their statistics on sports and so on, and also their content assets, so the text of their web pages in XML. And then they've got their journalists to annotate the assets according to a particular ontology. They've stored the results in an OWL and triple store. So in order to get answers to questions that combine both the Spark and the XQuery, so to be able to say something like, find me the league table for the English Premiership, where English Premiership is a concept in the ontology, and the actual league table data is in the XML. They've combined the Spark and the XQuery. And my last example here is from Nature, who have used Adobe XMP, which is a subset of RDF. They've embedded that in all their RDF documents, in all their XML documents, and the triple store of their RDF has enabled them to get a picture that goes across all their different XML data silos and really be able to build up a picture of all the XML content that they have. So we were very interested in all 3 of these examples. So this is OUP's system architecture. We've got a lot of different CMSs, as you can see. We're trying to merge our data together into our main MarkLogic CMS, but we've still got some way to go before we've done that. Our pre-ingestion layer is a Perl wrapper that sucks in the XML and creates XML-based metadata from that. And that goes into the OxMeta schema XML. If you come up here to the metadata hub, what we've actually got at the moment is an XML file store, which is indexed with a Solar index. And separately to that, we've stored our links in a triple store. And that's all accessed via a REST API, which combines Sparkle into the triple store and Solar queries into the XML file store. And then when it goes up to the Pub Factory repository, which is our web developer, their front end, we actually pull together the links back into the XML and it's published as XML. So it's quite a complicated setup that we have here, but this is the way that we're generating new types of links via querying the REST API. So Sean developed the OxMeta ML XML schema for metadata, which is a single vocabulary for the metadata for all our products. Because all our products are coming from different sources, which have varying DTDs or might not have a DTD at all. So they're coming from MarkLogic or FileMaker databases. We've got SQL Server, we've even got Excel spreadsheets. So it's all a bit of a nightmare, but we brought it together with one metadata schema. And this reuses some Dublin core vocabulary, plus it's also got terms based on our own particular needs. So the links can either be embedded in the XML metadata documents, or they can be standalone OxMeta link ML documents. And we've got different predicates like is author of, is related to, is primary topic of. And this is getting published, as I mentioned, for an externally developed product website platform. So it's still very document-centric. But we're starting to think about concepts like author, which isn't really belonging to any particular document. It's much more a separate idea, and one particular author might author quite a few different documents. And we're able to give these identifiers. We're starting to look at the ORCID identifier schema, which mainly comes from researchers in journals, but we're thinking about how we might be able to expand that out to our other authors. So that's one reason we want to think about what we could do with graph stores. So it's quite a different mindset to think about graphs versus hierarchies in XML. So with XML you're thinking about documents, you've got elements, you've got sequential order, you've got your tree basically. But in RDF you've got vertices and arcs, and you're thinking about the concepts and the relationships between them. It's much more difficult to manipulate relationships in XML. Some people have said, okay, well you're going to have your XML for your content, for your documents, and you can have your RDF for your metadata. But at the moment our metadata includes abstracts, and we've also got this requirement that we have to output it to XML to publish it. But as more concepts in the XML become linked in their own right, like the example I have with the authors, and they get given their own identifiers, we're expecting to migrate more of the XML to the graph model. So we're still quite at the development stage of our RDF model, because we're starting to see we've got two types of metadata. So we've got the bibliographic information, so things like the title or the ISBN, and at the moment the author. But then we're starting to get more semantic or contextual information, so stuff about what the document's really about, so what academic subject it's referring to, whether it's a person, an organisation, and so on. And so we're really thinking about whether we should change our RDF model or have them as two separate graphs, say. So the other way we can start to increase the amount of semantic information we've got is to link to an external RDF or OWL ontology of background knowledge, so that we could reuse those links back between our XML documents. So I've got an example of that here. This is looking at the area of American history. So we've got 3 XML documents. We've got John Adams, we've got a document about John Quincy Adams, and we've got one about George Washington. So these are all documents with particular titles, and we can identify, based on those titles, that they have the topic of John Adams, George Washington, and John Quincy Adams. And in our RDF graph, we would be able to say, okay, so John Adams is the father of John Quincy Adams and the successor of George Washington. The nice thing about that is that we can then start to link from our version of George Washington out to DBpedia or to the New York Times. And because they've also already got a lot of information about them, we can start to pull that back into our triple store. So that's the idea that we have about where we'd like to be heading with this. But as it's already been mentioned, RDF is really a data model and not a syntax. And my advice is not to use RDF XML at all, especially if you're an XML expert, because then you still tend to think in your XML way, and you're not thinking about the RDF graph. So when you're working on an RDF schema, there are 2 things you need to think about. What concepts are we trying to encode, and what are the relationships between them? You don't care about the element order. You don't care about whether you're using RDF description or RDF about. It doesn't matter. You can really concentrate on the knowledge modelling if you use something like Turtle rather than RDF XML. It's also less verbose, and you've got less variation in syntax. So our RDF data model, we started using the friend of a friend vocabulary, so it's probably topic of. We've also got some elements of Dublin Core, and we've been exploring Prism and Bebo vocabularies as well. But what we want to do is pick and choose for the information that we want to model, and not necessarily just take somebody's entire vocabulary. We've also experimented with whether we should store inverse triples, or generate them from Sparkle queries, or just use inference to generate them. And I'll explain what I mean by that. So here's some Turtle. I've simplified it somewhat because you'd normally have a prefix to explain what OP or FOF are, and then you'd have your angle brackets. But apart from that, this is basically it. So it's just URI, predicate, object. So what this is saying is that we've got a document about a topic that has got the name George Washington. That's the first three triples there. And then we're saying that this document, well, the topic, sorry, has its successor, which has got the name John Adams. And this has about half the number of lines of the RDF XML. And it's quite a lot easier to read. So the first thing we could do is encode the inverse triple explicitly. So we've got URI 456 has successor URI 789, and we could just say 789 is the successor of 456. Obviously, you need more storage if you're creating the inverse triples and storing them more explicitly. So the alternative that you could do is to infer the inverse triple using an inference engine. So by that, you just need to make sure you've stated that has successor as a property, and it's the inverse of is successor of, and your inference engine will pop out with the right answer. However, inferencing causes quite a lot of difficulty with deletion because the inference engine has to rebuild the index on all the logical conclusions that you've made now that you've removed some of your statements. So it's quite slow because it's got to check what the effect of those deleted statements were on any implicit triples. So we tried putting in some, or allowing inference in our schema, and it just really, really slowed down deletion. So we wanted to find another alternative. And this is what we're going to use, which is generating the inverse triple on the way out of the system to delivery as a query result. So this is just a bit of Sparkle. It's using construct rather than select, and it's just saying that I want you to return something which is the successor of 456, where 456 has successor this thing, and so it comes up with your correct result. So we found this was the best trade-off between performance versus database size. So the next problem we had was that because we're generating a lot of these links automatically, we want to be able to add in extra pieces of information about the links. So things like how accurate it is, the date of creation, whether somebody's checked it and approved it, and so on. And it's quite difficult to store a fourth piece of information in RDF. There's two main ways of doing it. The first one is named graphs or quads, but this is really more suitable to groups of triples. So for things like provenance, we might want to be able to say, here's our RDF graph, and it's being published by ADP. It starts to get a bit more complicated when you want to do that on an individual triple basis and make each one of them a separate graph. So we're kind of scared off by that idea. So what we've done instead is to use the RDF reification vocabulary, which assigns a separate URI to each triple and treats it as a resource in its own right. So we've got a URI who has the occupation of President of the United States. So we create a statement 1, 2, 3, 4, 5, and use the RDF subject, which was the original subject of our triple, RDF predicate, OP had occupation, and object president. And then we can start to add in extra information about this statement, which would say it was valid from the 20th of January 2009. And RDF provides nice vocabulary for this with statement, subject, and so on. However, we found that we're not entirely sure what was happening with this, but we found that it did seem to require some level of inference just to be able to link the statement to the subject. Because if we turned inference off in order that we could allow deletion in our triple store, we couldn't query at all. So we were like, this is a bit of a mess. So we couldn't use the reification vocabulary in order to be able to both query and delete triples. So our solution was, instead of using that vocabulary, to create a specific link class. So I've got an example here using our authorities, which are overview records for a particular topic. So it's linking authority record to OP has link, to our link class, and that link has a particular target, which was the object of our original triple. And that means we can hang all the information off our link object, so we can say that link has a particular accuracy, that link's got a particular match status, and here are all the other authorities that we decided shouldn't be linked. So that was our solution to reification and additional information to our triples. So I've talked quite a lot about RDF, and I haven't really talked anything about linked data. So linked data is about publishing connected information on the web. And these are the four main principles that Tim Berners-Lee set out about it. So you've got to use URIs as names of things, which we're doing. You've got to use HTTP URIs so that people can actually go away and look up those names and get data back. And when somebody looks up a URI, you want to provide useful RDF information. And then link from that RDF to other URIs so that they can discover related things. So we've done the first one. We haven't yet published any of our linked data, but so we have linked to an internal set of RDF information. So it's really talking about connections across content and not just documents, and it distinguishes between a document about Barack Obama and the man himself, and that's quite important, and something that often gets lost in publishing is that the people or the objects are quite separate from documents about them. And our DOIs really provide identifiers for documents, not data. So we still have quite a long way to go in this area. However, one of the problems with it is it's quite hard to see what the business models are for OEP. We can really see the internal benefits of RDF, storing links between XML documents, and using external RDF to augment our metadata. So one example of that is the Open Biological and Biomedical Ontology, OBO, which identifies gene names, and would like to be able to use that to identify gene names in abstracts. But the return on investment for publishing linked data is less clear. We do supply metadata to library services and aggregators like EBSCO and Summon, so we could do that via a linked data API. But it's less clear whether they would actually want to receive data in that format. The main business models that people use at the moment, the BBC and the British Library publish linked data for the common good, so that's really a subsidy model. The New York Times has the branding model, so they are a commercial organisation, but they're not making any money out of their linked data, they're just seeing it as a way of sort of getting to the forefront of technology and showing what a strong brand they have. We're sort of thinking about the freemium model, whereby you would sell valuable information, for example, particularly dictionary data, but you would give some of your information as free linked data just to whet people's appetites and promote your paid-for content. But again, that's really far from clear about whether that would be appropriate for us. What may be more interesting to us is the traffic model of linked data, whereby you're using your linked data to drive traffic to your website. And the first step along that road is to publish your RDF as embedded markup in your HTML. So this is what we're really thinking about, though we haven't actually implemented anything like this yet. So RDFA is RDF in attributes, and schema.org is a simpler form of markup within HTML. And the advantage of this is that it can really improve click-through rates because the search results are more eye-catching. So I think this one's actually a rich snippets, but it's the same kind of thing as you would get with schema.org or RDFA. So the search result is much more nuanced, structured results, basically. And a company in the States, a big retailer called Best Buy, did this with all their web data, and they reported a 30% increase in their click-through rates. So the example that we might have for some of our data using the schema.org vocabulary for person would be that we would have our information about Barack Obama with his name, his job title, and his birth date. So that's one thing we could do with schema.org. RDFA is better because it allows rich descriptions, and we would be able to provide all of our metadata embedded in the HTML. But schema.org is the one that's supported by the major search engines. And as well as the person example I showed, we could also use the creative work schema, which has things like book and article. But the drawback of schema.org is that you can only use a very simple markup, and it can really introduce semantic mismatch. So they've got a term, job title, but what we've got in our data is actually occupation. So for Barack Obama, it's occupation, American Democratic Statesman, and that's not really a job title. So you can see kind of the problem that you might get there. And finally, it's not a complete linked data publication either. So although it's a step along the way, it's still not necessarily where we want to be. So I don't think I've got any sort of big definite conclusions about our work so far, because we're still quite in the early days. We've definitely identified the internal business case for semantic technologies and link generation, namely search engine optimization and improving user journeys, but it's less clear what the linked data business model would be for us. We've still very much got that dichotomy of XML for documents and RDF for relationships, but there's still a question about how much of our XML metadata we should be moving into RDF. And finally, our experimental architecture of the XML file store for documents and a triple store for links, and then shoving them both together to output as HTML, whether that's really the most performant is still also an open question. So thank you very much, and anybody got any questions?
Any questions? Yes?
Yeah, on slide 6, you had Highwire shown as inputting into your store. Is it that way, or do you export to Highwire? I didn't quite see the relationship there.
Okay, so we have our XML that goes to Highwire, and then it comes back from Highwire, and we convert the XML to metadata and just take the metadata into our metadata store.
Okay, I was really interested about the traffic business model, but how would you make money on this, on the traffic?
It would be based on click-through rates. So it's not a. I don't think we've got a clear way of saying, okay, publishing linked data, it definitely increases our overall traffic to our site. But because it gives you a more eye-catching search result, that increases your click-through rate.
Jim?
Yeah, really interesting talk. Enjoyed it. Question I have, I'm seeing a pattern here when people are using XML and semantic web. There seems to be a sort of dissolution of the boundaries that documents has to the node level. Do you consider that a loss of fidelity? Are you losing information by going, because when you're reifying back, it's like you're making a dynamic document, aren't you? You're organizing a bunch of triples to say something as a group. Do you consider, is it a one-way flow of information? Is there a loss of fidelity in any of your processes now when you go from XML to triples?
We're not taking all the information from the XML to the triples. We're taking the links in one case, and then we're also considering what semantic information is in the XML. Particularly we have abstracts, and so we're saying, okay, we can identify genes, for example, or people names, and those go into the RDF. So I think it's more a question of keeping them linked, and we're not going to throw away the XML.
Okay, yeah. Two observations. The one is that I appreciate that you don't want to pick up a giant ontology, which you can only use 10%, but a lot of what you're modelling here does seem to be covered by the CDOC CRM and Forever OO, and there will be some advantage in using that vocabulary for interoperability. The other is about how you make money out of this. I think the basic kind of open source philosophy follows that it doesn't cost you anything to do it, and you don't lose, but you will gain if we all do it. If you expose your stuff out there, and I start putting annotations on it, using your identifiers, you can then scoop up my annotations and build products to make your products more worthwhile, so you'll get benefit from my work.
Unfortunately, I'm quite expensive, so my time and labour time at AEP does cost money. If we're going to publish our linked data, we would probably want to go with an external host who charge for that hosting cost. So it definitely costs money to actually do that application. So we need to show an internal benefit or a benefit.
Well, you could expose it via the people who would expose it to you for free. I mean, I'm sure there are lots of people who would host this stuff for you. Your university as a charity would expose it.
I think the TSO will host the triple store.
Yes, they do,
By
and they
the-
charge for it. So yeah, we've been talking to
Yeah.
TSO as well. Yeah, I think even there is still an amount of work you would have to do to get the data into a state that you would want to have somebody host it, even if we're offering to do it for free. But going back to your first question, I think we're quite similar to the last speaker in that we only want to have the terms, the concepts and the relationships that we already have data for, or we're getting semantics out of data for. So we're limiting ourselves to the terminology for that. So we're using friend of friend, we're using Dublin core terms already.
I worry a lot about the specific example you gave of has successor, because that's a very much private concept to you, which really can map to almost a million different things. One interprets that as meaning you think a successor president. I think that's what you meant by it.
Yeah.
But if I picked up that triple, it's really not very useful to me.
We haven't actually done that one. That was just an example of why we could do. Yeah, I mean, if we have that data that we can generate that link between the two concepts, then we would see what else is out there. I mean, one of the things we could do is if we map George Washington to DBpedia, and DBpedia already has a relationship that it uses between George Washington and John Adams, we're actually more likely just to reuse that link rather than decide the link for ourselves.
Okay, thanks Kathy.